Hi, I'm Leonardo Rodrigues Oliveira. I'm a Brazilian DevOps specialist working for Gestec, a Brazilian fintech, and I'm mainly working with infra as code, Kubernetes, and cloud computing. Today, I'm going to be showing you guys a little bit about how I make my own Terraform modules and how I've been doing that in different companies here in Brazil, big and medium companies and growing companies that need a very interesting infra as code strategy. And that's why I've gather this data, and I'm going to go directly to the technical bits. I'm mostly going to show you the code I did, and I'm gonna make the repository available on GitHub. So here we go. Let me introduce you to the concept of a Terraform module in a very brief manner. Any kind of repository or configuration you write in Terraform is considered to be a module. Since this module is considered the root module, which is a module that stands alone inside a directory and is the entry point for the calling of the module. It is mostly just TF files, and it basically has the main, the variables, and the outputs file, and it declares your configuration inside the module. Okay. But whenever you're in a high-level organization, you'll need more than that. And sometimes you will feel the need to have modules that can be used over and over again in different scenarios. Sometimes you have a module for, let's say, VMs, and you will need multiple VMs in different configurations inside your infrastructure. So the module for the VM can be used over and over again in these different configurations. We can set a parallel to traditional programming when we think about libraries or even Python modules, which are basically reusable code that somebody wrote in a given moment, and you can keep using it inside your company. And that's the same concept as Terraform modules, as the one that I was talking about, the VM module, but it can be used in a very, very broad manner. For example, you might need key vaults when working with Azure, and you might need different ones for different contexts. So it is possibly, it can be useful to have a central module that implements Azure Key Vaults in a specific way that your organization considers to be safe, with a specific naming pattern, with a specific access context or security context. And you don't need to write that configuration over and over again. You can simply refer to the module and then use it inside your configuration whenever needed. In that sense, it feels a little bit like having a inner source strategy, which is basically when you have an, let's say, open source initiative, but for the inside of your company. It's a inner sourcing strategy. When multiple squads, when multiple teams have access to the same code base, in this case, Terraform, and they can develop the modules, fork the modules, open pull requests, merge requests, depending on which tool you're using, open new issues, or fix existing issues. And in very large organizations, this is a wanted scenario most of the time, but it's also a not so easy to achieve scenario. And there's a few strategies that I'm going to share with you that helped me achieve this goal of having many people working on the same code base and not generating a lot of conflict. These are some side tips, but I'm going to get to them eventually. So let's first look at the module that I've written. So let's first look at the module that I've written for this presentation. Okay, it is basically a Terraform module written. I'm going to sample a little bit of the screen right here, and I feel this is far easier to read now probably. So it's basically a Terraform module that I've gotten online, and I'll make sure to share the link of the original repository on this repository somewhere. But I've made quite a lot of changes, and mostly I've removed stuff and I changed it a little bit to look a little more like my kind of configuration. But it is a very basic VPC module for AWS. And as you can see here, we have the basic structure of a Terraform module with the main file, with the outputs file and the variables file. But we also have a few others here, such as the subnets file and this directory right here, the examples basic. The main structure is, of course, main, outputs, and variables. All the rest is a little bit different from the most usual stuff, but I'm going to share with you the details on that. So on our main file, I have this header right here, which is a comment, and it's going to be read automatically by a tool that I use for generating automatic Terraform documentation. And also we have here the Terraform settings block, which is composed of a require version and a few informations on the AWS provider, which is the only required provider here, but we could have many others. And the only other thing that I add to this file right here is the AWS VPC resource, because this is a repository for a module that creates basic VPCs. So the main resource is the VPC, and that's why it's declared in the main file. So main resource, main file. As you can see, we don't have much information here. It's a very simple structure, but it serves our purpose. As you can see, we have the indentation using 2 spaces as the official docs recommend. We have a few blank lines to keep things a little easier to read, and it's a very basic file for Terraform. And as you can see, I named the AWS resource as this because it is the main resource in this module. It is not a very good thing to be naming the resources with something that is already part of the resource type name. For instance, if I named this AWS VPC as VPC, it would be redundant and I wouldn't get a lot from it. It would be just 2 times the same information, and it wouldn't be as clear as it could be. Sometimes we will have multiple resources, and this should be a little more useful. But in this case, it's very simple. Also in this structure, we have the subnets file, which is a Terraform file that creates subnets for our VPC. It can create many subnets, but it is quite simple, as you can see. The biggest difference here is that we use a count attribute to keep track of how many subnets I'm creating for this module. And well, and in the variables file, there is a little something that I feel is quite useful to make your Terraform module more readable, more useful, which is to keep a single structure for the variables. First, the description, then the type of the variable, and then if present, default, validation, or sensitive. And also, if something is required, if something is a required information, it shouldn't have a default value. Sometimes I see people using the default value to input something like a blank string as the default value for a required string, but this tells Terraform that the variable is not required. So this wouldn't break at first. It would break later, and it makes it easier to introduce errors to your configuration. My philosophy is always fail fast, even with Terraform. So if a value is required, I will never let it have a default value. So Terraform understands the lack of a default value and the lack of a variable in the configuration, and the lack of a value in the configuration as a mistake, and it will break as soon as possible, giving you more time to understand what went wrong and fix what you need to fix before the configuration is actually used. Also, sometimes we see configurations in Terraform, modules in Terraform that don't have a clear description for the variables, that don't have types for their variables, or use the any type. And that is also a way of making it easier to introduce errors inside your configuration. To avoid that, the type and the description need to be well chosen. The description needs to actually tell the user, the developer, the DevOps professional that what that variable means and how it will be used. The type makes it easier for Terraform and the user to understand what kinds of informations can be input to that variable. Now back to the main folder, to the root of the repository, we have the outputs file, which is a very interesting file. It shows us a few informations of our module, of the resources deployed by our module, and it should not be empty. Most of the time, you should, when developing a module for a company to be used over and over again, this should show something like this with useful information, not only for someone who's reading the configuration, but also for other modules that can use the information from your configuration to deploy other resources or to create other configuration with Terraform. And now for the examples directory, we have the basic, and the basic shows us how to use this module in a very simple way, in the simplest of ways. And it has a few information, and it has some information here. The region, which is, I believe, Virginia. And here in the basic, we have a few useful information. We have some useful information, especially when we are trying to understand what this module actually does and how can I use it. it holds the simplest of ways to call this module from within some other configuration. And I could have multiple examples of different scenarios, and it gets a little bit trickier with heavier, more complex modules, but it is very useful, not only for people who are using your configuration, but also for people who are editing your configuration. These can be read by the official Terraform registry, and it shows as a directory inside of it. It is awesome for testing the module itself. So I like to add a little bit of more complexity than I have in this module right here. And so I create a CI/CD pipeline that whenever someone updates the module, it tests all the different implementations inside the examples and then destroy it to avoid costs and stuff like that. But it makes sure the module and the examples are up to date and that stuff didn't break with the updates. Also here we have the images directory, which is a directory that only holds the speaker card right here, and it is read by the main file to create this introduction right here. It is not that useful unless you want to have a little cover for your repository, but I'm just taking that out of the way. I also keep a git ignore. I don't remember where I got this at first, but it is very interesting. We have here the Terraform directory to avoid storing what is Terraform's equivalent to node modules inside the GitHub repository. We have here the TF state files, the crash log files, the TFRs, and a few others that are a little bit harder to find in an usual routine. I also added the log file for this specific case, but some people like to version it. I understand the recommendation is to version it, but for this specific case, I decided not to. You can easily remove this by deleting it or adding a exclamation point at the beginning of this line right here. I find it very useful to keep the editor config file inside my Terraform repositories. And this is the one that I use it for this example, but virtually anything can be used as long as it is agreed upon inside your organization. So it has a few useful info. It says UTF-8, line endings, Linux, indent size 2, which is the recommended indent size for Terraform using spaces, of course, and inserting a new line at the end of the file, trimming all the trailing white space at the end of the line and stuff like that. This file is able to keep everyone on the same page as how to configure an editor and avoid stuff like having different line endings depending on who made the pull request and generating a lot of conflict in the way. I also like to use Terraform Docs to generate my automatic README. I use it with a few specific configurations, and I use it to actually generate the README file. This is very simple because all I have to do is download Terraform Docs, and then I execute Terraform Docs at the current directory, and it replaces the README file with this very interesting one, which shows stuff like if the variable is required, remember I said no defaults for required variables. Well, this is able to read that, and it also shows any other kind of info needed in the module, such as the required version for Terraform, any required providers and their versions, the resources that this module deploys, and also the outputs and inputs it needs. It is free and it is maintained by the community. Also, we have the releases right here, and they hold a little bit of a secret of mine, which is I always treat my Terraform modules as APIs, and specifically the contract part. So if you take a look at the README once more, you'll see that you have 4 different informations, 4 kinds of inputs, and 2 of them are required, 2 of them are not required. So whenever you're using this configuration, you will have to pass, you will have to input these 2, and you don't actually have to input the other 2 because they have a default value. So this works like a contract. You will need to provide a string and a list of strings for these 2 variables in order to use the module. So I treat this as a semantic versioning system. And whenever we have a new variable or the type of the variable changes or the variable is no longer required in all cases, now we have a different contract. Now we can use this configuration. We have to use this configuration in a different way. It had a breaking change, which means a major update, and it bumps the first number of the semantic versioning code, the semantic versioning tagging. And this has actually been done in this module right here. As you can see, we have 2 different tags, and we can compare them to see, besides a lot of other updates, minor updates, we have a new default value. In version 1, this variable was required, and now in version 2, it has a default value, which means it is no longer required. It became optional. And you might say, I don't want to use this kind of network, so your module is useless for me. And that's not true, because we can also override this value by providing a different input to this optional variable right here. So just to wrap it up, we took a look at how I build these Terraform modules and how I keep them clean and friendly for those who are opening their first issues, who are editing them for the first time, or those who just need to understand them in the first place. But I also showed you a little bit of tooling that I use to make it even easier to work with. Some kinds of a strategy to organize the semantic versioning of Terraform and the modules, avoiding breaking everyone who's using your configuration every time a feature is developed inside the module. And also a little bit about how to document it using a dynamic tool. You can also use the official registry for Terraform. It creates an even more complete version of the docs. I like it very much. But in case you're trying to do something for now outside the registry, you can use Terraform Docs, and the results will be those that I showed you. Also, I feel that Terraform is always advancing and getting bigger and getting more complex. And these kinds of best practices and recommendations are very useful within the community. So if you have any kind of insight, if you have any kind of tip you'd like to share with everyone, I feel it would be great to have it inside this repository or somewhere else. So go ahead, open an issue, add a comment, and tell me what did I do that you don't agree with, or you should be added to this repository, to these best practices in building Terraform modules for big corporations. And well, thank you. I'm available on LinkedIn and GitHub if you have any questions about the topics that I showed you here today, or if you just want to say something about Terraform, you feel it's going to be useful for me. I'm always there, and until next time.